from last week, we had, yeah, I think I'd shown you the link to this video. This is a good video worth watching. It showed you the details of the faucet as well. And I think I'd shown you the validators in action. I've got links there to Foundry. We'll be going through that this week anyway, and some links to wallets as well. But I just wanted to finish off this as well. So this was in the notes. We will come on to this anyway in this lesson, but it was there in the notes. So I don't know if anybody had a chance to look at it, but it's a question that we're going to be considering with an application of how to lock some functionality within a contract. And one way to do that is to use the pre-image of a hash as a secret, and then you can test within a contract when somebody inputs what they claim is that secret. You can then test that by taking a hash of that and seeing if it matches. So that's one thing we're going to be looking at this lesson. And I had some questions, but we'll come on to those. But that was really just the end of the notes from lesson 2 that I wanted to go through. Okay, so let's move on to lesson 3. Oh no, sorry. Before I do that, I also saw that there's in the documentation has been changing quite a lot. I have to say, but there's I did see there's some points about best practices. So I just wanted to quickly talk about this before we go on, just because we've been talking about some optimisations. Some of them may be less applicable. I mean, the first one here is particularly talking about how you can host dApps. So we're not really sort of concentrating on that. We will look at the sort of client side a little bit, but we're not really concentrating on that at the moment. Other points though, if you are making calls, see if this is something that you can predict. So we've got the point here of having RPC calls. If you're doing this to get the chain ID, when you know what the answer is going to be, then yeah, you don't need to do that, etc. So there are some shortcuts you can take because of the way the test network is set up at the moment. Similarly, if you can work out what the gas is going to be, then obviously you can do that. And the point here is about indexes. So there are services set up that gather events and put those into, or make those queryable, in a quite an efficient way. So look at this idea. It may be better for you than trying to listen for specific events, because they may already have been kind of extracted and be available to you off chain. So there's some details here about a couple of services that you can use for that, and that really addresses the question I think that we had earlier. Yes, so it's say the task requires automation where I need to send transactions where certain conditions are met. Well, you could indeed use something like this. So if those conditions involve events that are being emitted, then you could use one of these services. Obviously, you're going to have to then write some type of process off chain that is going to be looking at these and then responding by sending transactions, if that's what you meant by the certain conditions being met. If it's more general, then, well, you can still use the same type of approach, but maybe you're not going to be using these indexing services. But they're available anyway for you to use. Yeah, also you can do things like the graph as well. Other points that you can do. The managing nonces locally, what this is about is that if you are, when you're writing a client, you may the transaction will use a nonce, a counter to which can be then used to check whether the transactions are in the correct order. Now, one thing you can do when you are interacting is to go to the chain and get the latest nonce, and then make sure as you're creating a new transaction, the nonce is increased by 1. So if you're doing that kind of functionality, then that's a possibility. But if you do that every time, then you're making unnecessary calls. So what you can do instead is, if you have multiple transactions and you know that that particular account is not going to be used elsewhere. So if this particular piece of code is the only source of transactions for that particular account, then you can manage the nonces locally, because rather than having to go to the chain to get the latest nonce value, you can just have a local counter stored and update that, and then send those off. Which is details, some further details there. Also, so I hope those are useful. But this is all part of the developer documentation, so do check that out. All right, let me go back to the notes. So I just wanted to start off as well with looking at some of the token standards. Now, you may question why do we have these? There's the good reason for having standards is that everybody who is developing in the ecosystem knows what to expect and knows what your contract is going to be doing, knows what the interface to your contract or to your assets is going to look like. And so this allows your code and your project to be more composable. And I'm sure we're very already quite aware of these, but since Monad is EVM compatible, then we do follow these standards as well. The most basic, the best known, is the ERC20 standard. This is for a fungible token, a very simple standard. Then also, we've got details of that there. So some of the standardized functions you have are things like transferring tokens, checking a balance. You can set up approvals so somebody else can transfer tokens on your behalf. And because these are standardized, this means that everybody can know how to interact with your token, your ERC20 token, such as the next point here. If you put this token on a DEX, then it will work because the DEX will know how to handle with that. So obviously it makes sense to follow the standards as much as possible. All right. And there's some examples of there's many ERC20 tokens available. One point where some of these tokens do differ slightly is that you can specify the number of decimal places that a token has. That is not always the same for all tokens. So it's quite often 18, but it could be other values. So you may have to check what that is when you're using them. But that's more of a configuration change rather than a sort of change to the interface. Now the next standard we need to be aware of is the 721, the NFT standard. This has been very widely used. It's got many use cases. The essential point about it, what makes something non-fungible, is the point that it has a unique identity. So one of these tokens is distinguishable from another token, which is what non-fungible means. And because of that, then they are quite useful to be used for example, tokenizing assets or artworks, that kind of thing. And that's why we have NFTs. They've become very popular in DeFi, and so they will have a unique identifier. the point of a lot of the NFTs generally is that it's providing an ownership of some asset, and that asset is usually off-chain. So the NFT itself is sort of fully on-chain. That is holding details of the owner, but then that links via a URI to something off-chain, and that link is what is showing the ownership of that off-chain asset. Now, the on-chain part is kept as small as possible. The data stored on-chain is kept as small as possible because it costs to keep things on-chain, so it makes sense to reduce that cost. What that does mean, though, is that if we want reasonable functionality, then we usually want quite a bit of metadata around our NFT, and that then is usually stored off-chain. And as NFTs have become more complex, so we needed more metadata. But typical things you may have are things like a name, a description, an image. Now that might be the actual asset itself, or maybe that's going to be some kind of logo, and then the asset is going to be something different. We also have, you can have things more complex. It could be that your NFT is part of a collection, and perhaps your NFT is similar to other NFTs in the collection, but it just varies according to some attributes that will have possible values. So, for example, you could have it could be a type of cat, and your collection could be of some cats, but the cats could have different color of fur, or be I don't know, wearing different things or whatever it is. But those attributes are things that you can then create, off-chain. We can hold a lot of this data off-chain, but then it can be associated with a particular NFT on-chain, and that can show the ownership. All right, and there's a lot of use cases for the NFTs. So those were some of the earlier ones, but the standards have grown and grown, and we have got this another standard, the 1155 standard, that tries to bring together the features of the fungible and the non-fungible tokens within a within a single contract. So there can be advantages to this, because this means you don't have to write separate contracts for something that you're developing if it's using both fungible and non-fungible tokens. So you're going to cut down on the deployment costs. You're going to cut down on runtime costs because you're not having to call between contracts. Perhaps it also may be the case that you can do as it says, batch operations, because you can do things atomically, because they're within the same contract. It may be easier to do that, although it's not impossible to do that also in separate contracts. This also gives us flexibility because we've got both types available to us, and we can make gas efficiencies because everything is held together, and we know the types of operations that we want to do. So we can be more specific about what we're doing than if we had things being held separately, which may have to be more generic. And so some advantages or some use cases for that are for things like in-game items, currencies, etc., where you would have to have some kind of mix of the different types. So, for example, you may have within a game some kind of currency which would then make sense to have as an ERC20. This will be something fungible. You just have tokens, and you just have a balance of that, and that would make sense for that use case. But then also you would have some items within the game as well, but these would have some unique ID and therefore they will be more like an NFT. So it's a way of sort of putting the two together in quite a neat little package. Okay. Excuse me. Now, I want to go and talk on. I want to go on now to talk a little bit more about development. And we did have a poll last week where I asked you about your preferred toolchain, and I think it was split. I think there's slightly more people using Foundry than Hardhat. Now, I'm just going to talk really about Foundry, so apologies to the people who use Hardhat, although I guess if you're already using it, you perhaps don't need to know about it. But Foundry I think it's a very good product, and I say that for a couple of reasons. One is that it is very fast, and when you're doing tests, the tests run extremely quickly. I'm not sure I can show you a sort of very meaningful demonstration of that because I've only got some simple things which you're not going to see the speed really with that, but it is very fast. And I know just from experience that when I've demonstrated Foundry to people or they've started using it for the first time, that is a very common response that they've come back with. It's just this speed that it is very much quicker. And now you may say, well, why does this really matter? This is only testing we're talking about. But the point is that the way that we're working as developers, we're going around a loop. We've got this sort of iterative iteration. We're going around this loop of development where we are making some changes to our code. We're then testing it. That shows us some problems. And then we can make some more changes, and then we test it. And you're going around this many, many times. And so if you can reduce the time taken to go around this loop, then that will shorten the overall time it takes you to develop your project. It's also the case, I think, there's a couple of points about the way we develop as well that I think are worth considering. One is that it's to do with the way what you're thinking about as you're developing. You are concentrating, and you want to you want to be able to concentrate and do things fairly quickly and react to things fairly quickly. If something takes too long, then your concentration, you will lose concentration, and it'll be harder to sort of pick it back up, get your brain back to thinking about what you were doing. And then the second point, sort of related to that, is the fact that the tests themselves are written in Solidity, which then means that when you are writing your tests, running those tests, and then going back and writing your code, your brain doesn't need to switch back and forth between two different languages. And I think that is a benefit. I think that will help you sort of reduce the cognitive load. So there's two kind of positives there about the cognitive load, both kind of related, but which are helped, I think, by the fact that one, we've got the tests written in Solidity, so we don't have to switch back and forth. And then secondly, we can work much more quickly going around this loop, and therefore our brain isn't going to be picking up on other things or wandering while we're waiting for some tests to finish. So for all of those reasons, I think it's a great product. Also, I like it because it is introducing aspects around formal verification and more advanced testing. So it has fuzz testing, and it's had that for a long time, but it's also got some more advanced testing techniques and more advanced verification techniques that I think they're really designed for the more advanced developer, but there is little else out there for those people. So these tools they're very useful. So yeah, lots of good stuff in Foundry, but obviously you need to have a look and make your own mind about that. So how do we set it up? Well, there's I think let me just I need to update the notes. There's there's details in the documentation, or you can look at the Foundry docs as well. There's a link there will show you how to install it on different operating systems. Now, when you do install it, you can it will install Foundry, and it sets you up with a boilerplate project as an example. You can also get it to create a one that is more configured towards Monad. So when you start Foundry, you can either do Forge in it and then some project name, which will start just a generic project, but not configured for Monad, or you can use this flag here, in which case it will configure it slightly towards Monad. Now, what I have done is I was hoping that this code space would still be running. Excuse me. So I set up a code space. I just really followed this flow here. I created a code space, which I find them very useful on GitHub. If you're doing something simple, they're quite handy. You just need a repo. You can start a code space on that, and it gives you a nice environment. So you don't have to install things locally, and it gives you VS Code, and you've got a terminal. You've got a little Linux environment, so you can install other things. So yeah, it's very handy for that. So all I did was I followed these instructions. So for installing Foundry, and hopefully that's still yes, it is still there. And then what I did was I set up a project with this command, so that it was a Monad specific one. So what that looks like is let me close that. What it looks like is shown here. So you've got so I call it bootcamp. You've got the source directory, which has an example Solidity file here called counter, so it's something very simple. We've got a little test directory with some tests in it, and then it also has the Open Zeppelin contracts available to you as well. So, for example, yeah, we've got things, yeah, all sorts of, yeah, also just the general ones you would expect. For example, portable. That's an interesting, common one that you may want to use. So all of these are available as well. And then where have I gone? Sorry, let me go back. And then the configuration of Foundry is done in this TOML file, which most of this is standard. It's just giving you the directories that are used for the source and the output and the libraries you're using. But then also we've got some specific configuration here, so you can see it's got a link to the testnet and it got the chain ID set up as well. So that's already set up for you. It's not much different to the normal, the ordinary Foundry setup, but yeah, it's there anyway. If you haven't used it before, this here. So to start it, you're going to use the forge command, and then what you're going to most likely do is forge build and forge test. So initially, but obviously you can see here there are lots of other commands that you can use. So I can just I can show you the example. Oh, I'm in the wrong place. Okay, so you just need to go into the correct directory, and you can see there it's compiled everything, and then I can run the tests as well. It's run very quickly. The tests, I mean, they're not complex anyway, but you can see it does give you some details there. The tests themselves, let me just quickly talk about those. So they're written in Solidity, which I think is useful because it avoids having to switch to other languages. So you can see here what we are doing is we're setting up a test which is for this contract, the counter contract. So we've the way that we do that, the way that we name the file is to call it counter.t.sol to show that it's a test. When we actually create the test contract, we have to inherit. So from test, so we do counter test is test. So that will inherit from the standard test file. We need an instance of the contract we are testing within the test here. You have a function to do some setup, so that's fairly standard with unit tests. You would do some setup, and then it will run the tests that you specify here. So we've got one that is testing increment, which I think that's probably the only function in counter anyway. And then, oh no, sorry, it is not, is it? We've got two. We've got increment, which bumps up the amount by 1, and then we've got one that will set the number. So increment, a simple test there. I think that's probably, I don't know, it does make some assumptions here, I guess, that we are assuming with this test that we've run this setup because we're assuming that we're starting at 0. Therefore, when we do the increment, we're going to end up at 1. You could, of course, try reading the value and then doing the increment and showing that it's increased. But okay, small point. Now, the fuzz testing here is with a fuzz test, what you do is you write what looks like a normal test, but you include a parameter here. And what Foundry will do is to then put some random values in there so that you can see maybe you'll find some edge case that you wouldn't have thought of. A point about that really is that when you're testing, you're looking for circumstances that the developer, which may well be you, hasn't thought about. You're looking to try to get away from maybe some of the assumptions that the developer has made. And so fuzz testing can be quite a good way to do that because it's putting in some random numbers. So it could end up showing some circumstance that you hadn't thought of. So what we've got here is we're inputting some random value X, we're setting that number within the counter, and then we're making sure that is the actual value that has been stored. Now, you can't see how this would necessarily fail, but obviously if you had something more sophisticated, then this could well be a valuable test to have. You can also you can write your test so that with the random values are kept within a range, which probably makes sense because there's only a limited amount of times that you're going to want to run this fuzz test. Obviously you've got a limited amount of time available. So if there are certain ranges that you don't need to test, then it's good to exclude those in the fuzz testing. Okay, let me quickly look at the questions. Who issues the ERC standards, and is there a developer community drafting their own standards? So I don't actually, I'll have to find out for you about the process. What usually happens is each blockchain will have some procedure there of governance. Now, it may not be very well specified, so it could be more down to convention than anything. But with the ERC standards, they they are open for discussion. They are published. They are open for discussion. People can go in and argue about them. You can propose your own standards. But I'll find out, the details of what's happening with Monad. But I imagine there'll be something similar, a sort of similar process. So it can be a little bit ad hoc, but there is usually some process that you can find out about that will allow you to interact with it. Okay. Can I help you with the source code after the class? I'm afraid I won't have time for that. But if you want to put some specifics in Slido, I can try to help, or if you put it into technical questions. So if you have some specific questions, you've got some specific problems, then try to demonstrate those, and I'll see if I can help you with that. Okay. What I would say, if the best thing to do is really just to keep practicing. If you're having problems, try out different examples and look at the examples, the tutorials and the guides that are available. One of the useful things about Monad is that in terms of development, 99% of what you have to think about is the same as what you would have to think about in developing for the EVM. It's really the differences are around things like gas and the cost and the speed of the transaction. But in terms of the Solidity code and how that works, that's going to be the same. So if you do have problems, you may well be able to find answers, if not on Monad, then on maybe other EVM compatible chains. Someone may well have had a similar problem and may be able to help you with that. Okay. All right. So that that was just looking at the testing. Let me also show you something that is useful. You can also, when you're running your test, you can get it to give you a gas report. So there is this flag here, gas report, which will produce that. Now the other flag here as well is the verbosity. So what I've done here is I've put 4 V's, which means I get lots of detail coming back. I get lots of verbosity in the what has been happening. So as you can see here, it's running the test and then tracing what is happening within the contract. So you're getting a lot of detail. You can set that flag to be, you can be less detailed or more detailed. It's up to you how much detail you want to see. But then the gas report here is very useful if you're at the stage where you are optimizing your code. Then you can start to look at this. The main things to look at in the report. One is the deployment cost here. So this is going to tell you how much gas it costs to deploy your contract. This is really an indication, of the amount of bytecode in your contract, and you may want to optimize for that. That's one possibility, one thing you may want to optimize for. The other possibility is you may want to optimize for runtime behavior, and that runtime behavior could be will be calling various functions. So you can see here it shows the functions that have been called while it was doing the test, and then it gives examples, or it has some statistics about the amount of gas that was needed when those particular functions were called. Of course, those functions could be called from different tests within your test file. So there may well be a range of values. It's not just the case you're going to be calling it only once. So that's why you are seeing those, and you get examples of the maximum, minimum, and then the average and the median there, and then the number of calls. Of course, here the increment gets called once because it's there. The number and set number get called more times because they're part of a fuzz test. So it's calling this doing this test many times, so they get called many times. Yeah, so interesting. One point about that that is worth having a look at is sometimes you find, you may find quite large differences between the cost when things are being called. That can be significant as well. So, for example, here we've got the set number has quite a large range, and you may want to have a think about that. See if you can work out why that would be. So just to show you the code. So this is what we're calling, and we've called this many times with some random values, and we're getting quite different results in the amount of gas that is being used for that. So yeah, I'll leave that for you to have a think about that, as to why we would get such a difference. There's a couple of reasons, I think, but yeah, we can discuss that a little bit later. So the question, about there's a question about Anvil. So see if I can easily get that. I'm gonna try and do this on a separate terminal. So when you install Foundry, it installs a number of binaries that you can use. Let me see if I can. I don't know if I've got the. I want to find the. I don't have the. Sorry, let me go back. Here we go. This is what I want. This book, the Foundry book, is invaluable, and the bit that was linked to is how to install it. But it also tells you about the different binaries that are available to you. So we've got details of testing there as well, but and gas reports. But then also here we've got these other binaries. So we've got cast, anvil, and chisel. Now, so they're asking about. So someone asked about anvil. So So what this has done, very quickly. I just typed anvil. This runs a local node for you. Now this is. This in Foundry is just going to be an just a standard EVM node. It's not a monad node. So I don't think. So you can still test. I think it's okay to do some testing, just generally of solidity. But then obviously some you will need to do on specific monad nodes. Because they are working slightly differently, so you will need to do some of that with Anvil. Let me go back to the. You can, you can specify. You can set it up so that it can do either just a very generic EVM node, or it can do more specific things. You can put in URLs. So, for example, here what it's doing is a fork, so it's doing the fork of a chain. So you could use that. For example, you could do a fork of the testnet. I don't know if I've got that in the. I may have that. Sorry, let me go back to the notes. I may have those details actually in the notes. Sorry about jumping around. Okay, I just really got I think I've just got the deployment there. But you can, you can make it more specific with Anvil by doing a fork of a particular chain. The other binaries that are available, one is chisel, which is a REPL. So what that allows you to do is I'll just show you in the notes here. We don't have that much time. It allows you to set up single lines of code. And so, for example, here you're just writing a single line of Solidity, creating a storage slot and assigning a value into it, and then by typing the variable name, it will bring back details of that storage slot. So you can just go through and write little bits of code like that and get immediate feedback without having to write a full contract. And then perhaps the most powerful one is Cast, which can do lots of things. I can't remember where. There's a list. Oh, here we go, the Cast reference. This shows you the different types of things that are possible. It allows you to interact with chains and get lots of details, for example, about transactions. It's one useful thing it can do is to, if you have created a transaction, if you've run a transaction and it has reverted, you can use Cast to rerun that and get a lot of detail about what actually happened, and you can often find out why it reverted. So yeah, but it has so many useful pieces to it that I don't have time to go through all of these. Okay. All right, so hopefully that's answered the questions there. So yeah, that was just where am I? No, sorry, I've lost my count. Yeah, so that's what Anvil looks like. And it sets up these accounts for you. So these are little test accounts that are created for you with keys. Yeah, do I need to say, if you use these, well, no, I think it's changed now. I think these are done at random now, so you're probably okay, but don't reuse the keys that you find in things like this, just in case. Yeah, anyway, that's Anvil running there. Let me move back. So I've shown you the gas report. That's what I wanted to do. So moving back to the notes. So this is details. We don't really have time to do it in the lesson, unfortunately. What I wanted to do was to go through and make things a little bit more interactive and do some more coding and get you more involved, ask you some questions, etc. But you can have a look at the notes. There's details here of putting together a project that uses an ERC 1155. It requires that you set up some metadata, so that's done in a JSON file, which that's going to be stored off chain, and where you store the metadata and an asset or assets, if you have them, is really up to you. But people often put them on decentralized file storage systems such as IPFS, but some people put them on centralized file storage systems such as AWS. It's really up to you where you want to store those. There's some details here of how you can set up the contract. One point here, the remappings that is useful. One useful thing about Foundry is that you can integrate hard hat and Foundry projects. So if you've got an existing hard hat project, you can set that up so that it will work in Foundry and vice versa. So you may find that useful. I did have just a small bit of code that there's an example here that you could have a look at. We've got some items, some game items that this contract is responsible for, and we've got it's allowing in this game it will mint certain numbers of these items. So you can see we've got some functions to do all of that. I can come back later to the access control. There's details here of how to actually get it to build it. Do try this out, but we don't. I have to kind of rush on really. And then when you want to deploy this, obviously you will need to interact with a node. So you can do that with a node provider, or just find a node on the network to act as an RPC node. The other way you could do it, if you don't want to use Foundry, obviously Foundry is a command line tool, so you need to do this approach. But if you didn't want to do that, if you wanted, you could also use something like Remix, which allows you to use a browser wallet such as MetaMask to interact with the blockchain. So there's other possibilities. Yeah, details. You set up the thing. Yeah, private key. Actually, there's better. You can use a private key. There are better ways. I think I've got some details out in the notes. If I've not, then I'll come back to that. But anyway, you can use that, and then that should allow you to deploy your contract. You can also verify your contract. Let me just go in the notes here. So within the documentation, as you can see, there's a section about the infrastructure and tooling that is quite useful. So yeah, you've got some RPC providers there that you can try. So yeah, they've got quick node as well. But also you've got block explorers. Hopefully this. Oh, okay, this is going to work for me. Okay, so you can use block explorers as well, and that should allow you also to verify contracts as well. I think you can on the on other explorers. Yeah, but you can. Sorry, I've lost where I am in my tab. Anyway, yeah, you can try that out. I do have. Yeah, so anyway, you try that out, try some of that code out. I'm sorry, I do have to rush on. The next point, what I wanted to show you is the idea that this concept of locking. So we wanted to put something in. The idea was creating this gift pack where we could lock items, and people will be able to unlock them. One way to do that is via a hash function, where you can have some secret created, and then this is hashed. The hashed value is put in the contract, and then the process of unlocking is by inputting that secret into the contract and then checking if the hash values are the same. So what I do have to finish in a second, so I'm sorry about that, but I'd like you to think about, we'll pick this up next time. This could be problematic, and can you think why? Yeah, what features of a chain would make that a problem, and is this true for Monad? So have a think about that. I'll also give you some more code about I'll put it in the notes. Actually, I've got an example code of doing hash locking, so I'll put that in the notes later today, and then you'll be able to go through that code before next week as well. All right, I'm sorry that I'm pretty much out of time. I'm not sure what else did we. Access control, I'm probably going to have to come back to. It is extremely important area. You have to make sure that the functions are only allowed to be called by the people you expect. So it's pretty much the case that there's usually going to be some access control on each function. What I think is useful when you are writing contracts is to work out roles for different addresses, work out the roles within the system, within your project, and then assign addresses to those roles, and then look at the functions and see which role is needed for those particular functions, and follow this principle of least privilege, as in lock down things as much as you can initially, and then only gradually open things up where you absolutely have to, and that will hopefully be a little safer, because access control is one area that tends to get exploited quite a lot, so you have to be very careful about it. Apologies, I have to finish there. I will add to these notes, so please do update them a little later, and if you have questions, you can put them on Slido or on Discord in the technical questions, and I'll get back to you there. All right, thank you for your attention today. It's much appreciated. And I look forward to seeing you all next week, where we'll finish this off and we'll go on to another example as well. All right, thanks everyone, and I'll see you all next week.
Thank you very much, Laurence. And quick mention again, make sure that some of the questions I've seen in chat, make sure you're putting them in the Slido so that Laurence can see them and save them and answer them at the start of next session. I've linked it in the chat, so it will stay there when we close the session now. Thank you for joining us, everyone. We will see you next week.